And now it is time for the fourth presentation for today. So may I introduce Corina Cimpanu, and she will talk about engaging students in e-learning environments for micro-learning.
Thank you so much. Good afternoon, everyone. My name is Corina Cimpanu, and I come from the Gheorghe Asachi Technical University of Iași from Romania. My workshop today focuses on engaging students in e-learning environments for micro-learning, and my study case is on machine learning in knowledge representation and reasoning. I will invite all of you to open your laptops and or phones, maybe, and join the Google Meet that is posted on the right side of the slide. I couldn't get your emails beforehand, so I had to improvise the invitation. Oh, okay, so this is how the Google Meet looks like. Why did I use it? Because I wanted to share with you the documents for the meeting, which are organized on Google Drive. I will post them on the message chat, so you can access all that information. We are going to have a folder that contains the MATLAB code that we are going to use today, a collaborative document where you will be able to write your results on the experiments, some instructions, some README details for using all this stuff, the workshop material, which is a lab material for an interval of 6 hours. It has 72 pages, but we will try to compress it today just in 1 hour. Okay. Additionally, I have some other documents, which are some output results of pre-run experiments in case you don't have MATLAB on your computers. Okay, let's switch back to the presentation. I just showed you the content of the folder on Google Drive. Here is the MATLAB code which you can download and unzip and use afterwards. We can use it on MATLAB Online, which is matlab.mathworks.com, where we have a MATLAB drive where we can copy the code and then run it online, just like the classical MATLAB. This is how we can use MATLAB. Even if you don't have an academic license for it, you can work on MATLAB Online for 20 hours per month for free use. This is a picture where I show you how to import the code to MATLAB Online. What do we have there? We have a document, a collaborative document that looks like this. We have a tree view that helps us navigate through it because it's a bit large. We have some results for a partition on the data set, and we have empty tables for the other 2 partitions of the data set. In this document, you will be able to write your own results. And I will ask you to choose a table and a set of experiments to write your results on. Okay. Going back to my presentation. I was talking about machine learning, and machine learning refers to the process where machines are trained to recognize patterns and to learn from data, and to make predictions on that data and decisions without being explicitly programmed for every scenario. I will get you to the session outline. We will get through the data set that we are going to use today, some practical demonstration on support vector machines, key nearest neighbors, and random forest algorithms, extracting information and interpreting model outputs for reasoning. Here are some reasoning mechanisms that we can use in machine learning. Deductive reasoning, inductive reasoning, abductive reasoning, or analogical reasoning. And here is the data set that we are going to use. It's a medical data set. It's called the Wisconsin Breast Cancer data set. The first column is the patient ID, the second column is the diagnosis, and the following 30 columns represent the attributes that we are going to use. I have extracted all this information. So I processed the columns for 3 to 32, and I put them in a matrix that is called X, and I extracted the column that contains the diagnosis in a vector column called Y. The class distribution, the sample to class distribution that we have in the vector Y is presented here. So we have an unbalanced case of classification. And here are the details about the features that we are going to use for classification. Here is an insight of the MATLAB data that we are going to use behind our experiments. Here is the matrix X and the column vector Y. And here are the scripts that we are going to use. We are going to go to the main files. We have 3 main files for each algorithm. And we are going to modify some data inside them in order to get to our experiment. Okay, let's go to support vector machine. I will switch back to MATLAB Online. Here I have my main for the support vector machine. So what we are going to do is we are going to look at the data partitions that we have available. The results that are already given in the document are for partitions data.mat. And the partitions that you are going to work on are the partitions data2.mat and partitions data3.mat. This is a 70 to 30 partition, and this is a 50 to 50% partition. So we will have to modify the partition over here, where we are going to pick partition 2. And we are going to modify also the percents. So it will correspond with the results that we are going to get, like this. And in the end, also the results file should be named accordingly. What do we have between these initial and final points? We have 5 support vector machine models with different kernel functions and different parameters. We are training these models on the training dataset, and we are predicting their performances on both training and testing datasets. The training dataset in this case will have 70% of the whole data, while the testing dataset will have 30% of the whole data. The results will be printed in the following code. And the best model that we get in the first set of experiments will be considered in another series of experiments that compares the original data to noisy data or to redundant data. And here we have the code for it. To run all this, we have to press run here. Or if you don't have MATLAB, you can go to output results for 70 to 30 partition, and you can get your results there. What you have to do today is match the results from the output that we have here to the tables in the collaborative document in the second section. Okay, I have also in the end of this document an attendance list where you can write your email address. Let me send it to you. If you open the instructions and the README file, you have the links to MATLAB Online, to the workshop content, to the shared code folder, and to the collaborative document. And also in the collaborative document, in the beginning, you have the results. Then you have a link to the document that has the pre-run results for the 70 to the 30 partition. And on the third side of the document, you have the link to the pre-run results for the 50 to the 50 partition. So you have to create firstly a folder on your MATLAB drive where we should import all the scripts. And the main scripts are the main programs that you have to run. They are based on the other scripts. They are calling the other scripts. Main SVM first. And you have to modify on the first load partitions data 2 in order to select the 70 to the 30% partition. And if you want to log your activity in your command window, you can add diary and the text name and the text file name in which you will save all the information over here. This diary should be finished with a diary of at the end of the code. Also, you have to rename the results file accordingly to the partition that we are running the test, so it doesn't overwrite the other mat file that is there. And you should get something like this. Okay, from all these results, we are going to choose the model that gives us the best accuracy for the test set. So we have the model evaluated on the trained data and on the testing data. Here you can observe the data set. And we have to look for the best accuracy.
With the highest accuracy on the test data set.
Ones of you that already got some results, I invite you to add them to the collaborative document. You can write your own name on top of a table that you choose and post the results inside the table. Yes, you can do copy and paste, or you can use ChatGPT to organize it as a table. It's faster. Firstly, pick a table of your own and add your name on top of that table. So your colleagues will know that you are working on that table and they won't interfere on that content. Okay, so after we have the code uploaded onto the MATLAB drive, as shown here, we can run the script. What does it assume to run a script? It assumes to double-click on it like this, open the script, and we have a button that is called Run. And you are going to execute that code. I'm telling this for the people that are doing this for the first time. The micro-learning units behind it are the classifiers mainly. The parameters that are used in configuring their settings, and the way they behave, the results they obtain. And what I wanted to get from you was to fill in these tables with data. You were running the experiments on the same initial data, as you already seen, because you have here some mat files that are the same initial partitions. So all of you have the same initial conditions. So you should obtain similar results on this data and should be comparable at the end. I was splitting the content of the laboratory work, which is of 72 pages, about each classifier and the way a classifier like support vector machine behaves in terms of knowledge representation or in terms of reasoning. How it separates two classes. Here is the two-dimensional example. Okay. Yes. You have just one unit of the whole laboratory. Then we are going to KNN. And then we are going to random forest. At the end, we will have a comparison between all these classifiers. And we will try to identify the way they behave in terms of training time, prediction time, model complexity, what data each model stores behind it, how it handles nonlinear data, the robustness to noise, the interpretability, the scalability, and the feature importance. If you are looking on the 80 to 20 partition, you can see that I already did that. Here we have the model complexity, so we can see the differences between the three classifiers over here. Then I have the training time and the prediction time. This is the time expected in theory, and we are trying to see if it matches. Then we have the ability of handling nonlinear data, which is here. For each configuration, it was the methodology that I was using in my, my workshop. Here we have some details about the support vector machine classifier, how it can classify data and form decision boundaries for reasoning. These are the main features that the support vector machine has. It uses data as vectors in feature space. It uses support vectors as key knowledge holders and uses kernel trick for complex representations. Here we have an image of geometric reasoning that the support vector machine can do in a two-dimensional space by maximizing the margin between different classes. For KNN, I don't know if you tried to run those experiments. We have a similarity-based approach in reasoning. We have, in this case, instance-based learning that applies distance metrics, different distance metrics to obtain the nearest neighbors to a sample. A voting system for classification that allows us to select a class based on the majority vote amongst its neighbors. And we have to focus our experiments on choosing the hyperparameters that are better for the results we are going to get. As method of reasoning, we have similarity-based reasoning for the classifier. Then we have the random forest algorithm. Its main particularities are based on decision trees, mainly ensemble of decision trees that are used by majority voting to establish the result. If we are going to have results in the collaborative folder, if you are going to fill in the results for the 70-30 and 50-50 partition, we are going to be able to draw some conclusions about the models we are working with. These conclusions should be related to the model complexity, to the training time, to the prediction time, to the way the classifier handles nonlinear data, to its robustness to noise, to its scalability and feature importance. Okay. In the end, I would like to show you an word cloud that I was going to make with your help. You can scan this QR code. And I invite you to add over there 5 terms that you consider the most relevant for the information that you worked with during this hour. We have some words that are related to the content. we have some words that are related to the feelings you had trying to do the experiments and the whole process, which is normal. Usually this tool is used to measure the amount of understanding on a certain topic. You can compare your own results with the results obtained by inserting or inputting the original text into the menti.com. If you get the same words, you're good. So we have complex, we have difficult, we have ratio, which is related to the partitions, the data partitions that we were studying over there. We have classification, we have the tool that we are using to obtain our results, which is MATLAB. We have machine learning, which is the topic. We have the kernel trick from supervector machine. We have the drag and drop operation that we had to do when uploading your code to MATLAB. Okay. If we get more than 3 participants to answer. Okay, I needed your email address because I wanted to send you an online questionnaire that is organized in 4 sections. The first one is configured for acknowledging the target group. The second one covers the workshop content. The third one is used for assessing your learning style. And the last one is for studying the benefits of microlearning and how much you managed to obtain in terms of results during this hour of workshop. And I will provide you the results after the questionnaire is completed. Thank you for your attention.